Okay, so my name is Soren Larsen. I'm from the Astronomical Institute of Utrecht University in the Netherlands, and I'm mainly working on extragalactic star clusters actually. So I'm interested in how we can use star clusters on the one hand to learn something about their parent galaxies that they live in. So if we can determine the ages of individual clusters in a galaxy, we might be able to see, for example, if there was a burst of cluster formation and a burst of star formation sometime in the past. And if we can learn something about the chemical composition of the clusters, we might also learn something about the chemical history of the parent galaxy. So that's sort of my aims on one hand, and on the other hand, star clusters, of course, are made of individual stars, and they have a long history of being used as laboratories to study stellar evolution, so we can compare color magnitude diagrams of star clusters, for example, with predictions by theoretical models, and we can see if they fit or if they don't fit and what we might learn from that. One of the main questions that I'm trying to address in my research is to learn something about the evolutionary histories of spiral galaxies. So our own galaxy, the Milky Way, of course, is a spiral galaxy, and we know a lot about how the chemical composition of stars depends on age and position within our galaxy. But we don't know very much about that in other spiral galaxies, just because it's very difficult to observe the individual stars. And that's where the star clusters become very helpful, because we can actually identify them at large distances. And there we can use star clusters rather than individual stars. Now it will be difficult to use Gaia to learn much about extragalactic star clusters, but the strength about Gaia is what it will tell us about star clusters in our own galaxy, the Milky Way. So Gaia will tell us a lot about the star formation process, the early dynamical evolution of star clusters. So that helps us understand how effectively star clusters might trace star formation, for example. And also Gaia might actually uncover a number of star clusters that we didn't even know about before in the Milky Way. Yeah, Gaia will definitely help this research, again, mostly in the Milky Way. So in the Milky Way we will be able to use Gaia to identify groups of stars that have formed together, and Gaia will have some spectroscopic capability as well that may give us some information about chemical composition. And of course, once we have identified these groups of stars, one may also go and follow up with other instruments as well. So I think Gaia will influence my research, and it will influence, almost every aspect of galactic evolution and structure that one can think of.